Let's solve this question of integration by substitution. We have integral dx over 1 plus 3x square. There isn't any known formula that we can use directly to find the solution of this integral. So we are going to make substitution, but before that we know integral of 1 over 1 plus x square dx is equal to tan inverse x. But here in our question we have 1 plus 3x square. So we will try to put this 1 plus 3x square in this form like 1 plus x square. So we will write it as dx over 1 plus, we can write 3 as square root 3 x and whole square. When we open square root 3x whole square, we will see that square root 3 square is 3 and x square is x square. So it becomes just like before 3x square. But putting it in this form helps us to make the substitution. Now we are going to substitute square root 3x equal to another variable. Before we make the substitution, we have to think that square root 3x derivative is also written here. But square root 3x derivative is square root 3 because x derivative is 1 and square root 3 is not written here separately. We will still go ahead with this substitution because square root 3 is a constant and constant would be adjusted later on. So square root 3x equal to 3, its differential is square root 3, dx is dt. It gives us dx is equal to dt by square root 3. We will plug square root 3x equal to t and dx is equal to dt by square root 3 in our formula. The value of dx is dt over square root 3, 1 plus square root 3x is equal to t and its square. We will take 1 over square root 3 out and inside we have dt over 1 plus t square. We can see that 1 over 1 plus t square dt is just like this integral 1 over 1 plus x square dx. So it can be written as by this formula 1 over square root 3 tan inverse t plus some constant. Since t was not originally the part of our question, so we will put here the value of t which is square root 3x, this one. So we can write 1 over square root 3 tan inverse and t is square root 3x plus some constant. This is how we solve this kind of question. We first rewrite our question so that it can be in the form 1 over 1 plus x square and then we make the substitution. Let's solve another question. We have to find the integral of e power square root x divided by square root x dx. Again, we are trying to solve this question by substitution. Here we have to substitute. So we are going to substitute this square root x equal to t. But before we make this substitution, we have to think that the derivative of square root x is also here. We know that the derivative of square root x is 1 over 2 x to power 1 by 2 minus 1, which is 1 over 2 x to power minus 1 by 2, which is 1 over 2 square root x. And we can see that the derivative of square root x is 1 over 2 square root x. Although 1 over 2 is not written here, but 1 over square root x is written here. So that is why the substitution of square root x equal to t is correct. So back to our question, square root x is equal to t and then we find the differential, that is 1 over 2 x to power minus 1 by 2 dx is equal to dt. How did we get this? We have x to power 1 by 2. Its derivative is 1 over 2 x to power 1 by 2 minus 1, which gives us 1 over 2 x to power minus 1 by 2. And we had written here directly. And then the differential of x, which is dx. Simplifying this gives us 1 over 2. We bring this x to power minus 1 by 2 down. So it becomes x to power 1 by 2, which can also be written as square root x. Dx is equal to dt gives us dx is equal to 2 square root x dt. Now let's put square root x equal to t and the value of dx in our integral here. When we do that, we have e power square root x is t divided by square root x is t and the value of dx is 2 square root x dt. We know that our substitution is correct if this whole integral is written in terms of t, but we can see here square root x, but that should not be a problem because we can write square root x equal to t from here divided by t dt. Now let's simplify. T cancels out with this t, so we have taken 2 out and integral e power t dt. See, the substitution square root x equal to t has made our integral very simple, which is e power t dt, and exponential function integral is back as the exponential function. So we have 2 into e power t plus some constant, but t was not originally or variable, so we will put the value of t, which was square root x plus some constant. This is how we solve this integral by substitution. Let's solve another integral. We have sine squared x cos x dx, and we have to solve this integral by substitution. The rule of substitution is from a complex part, take its tiny part and put it equal to another variable. Now we can see that we have written sine to power 2x as sine x to whole power. Whenever there is a positive power on a trigonometric function, it could be written as the whole power. Now inside the integral we have two parts. One is sine x whole square, another is cos x. So substitution says from a complex part, here the complex part is sine x whole square. Think of its tiny part. So I'm not just going to pick sine x whole square and put it equal to a variable t. I'm going to pick from sine x whole square its tiny part, that is sine x, and put it equal to t, because sine x derivative is cos x and cos x is here. So put sine x equal to t and then its differential. Derivative of sine x is cos x, dx is x differential and dt is t differential. Put this value of sine x equal to t and dx equal to dt by cos x in our main integral. So we have here in the place of sine we have t square and the cos x, and the value of dx is dt by cos x. This cos x cancels out with this cos x and we have t square dt. And now we can solve this integral by power rule of integration, which is t power 3 divided by 3 plus some constant. T was taken as sine x, so we will put sine x cube divided by 3 plus some constant, and we are done with this question by substitution. Let's solve this integral. T power 4 3 minus 5 t power 5 outside power is 1 by 3, and we have to integrate this expression with respect to t. Now we can see that in this integral we have two parts. One is t power 4 and another is complex part, which is 3 minus 5 t power 5 whole power 1 by 3. So what I am going to do is I am going to pick a small part of this complex expression, that is 3 minus 5 t power 5 and put this equal to another variable. But before that I have to check that the derivative of this expression is also written inside this integral. So the derivative of this expression 3 minus 5 t power 5 is derivative of 3 is 0 minus 5 the 25 t power 4. So derivative of this expression is minus 25 t power 4. The variable presence is important. Minus 25 is the constant. It is not here, but it would be adjusted later, but t power 4 is here. So yes, we will go ahead with this substitution and put this equal to another variable, let's say x. Differential of 3 is 0 minus 5. Differential of t power 5 is just like the derivative. So 5 t power 5 minus 1, which is 4, and differential of t, which is dt, is equal to differential of x, which is dx. So we have minus 25 t power 4 dt is equal to dx. We can find the value of dt from here, which is dx by minus 25 t power 4. Let's put in the value of dt and 3 minus 5 t power 5 equal to x back in our integral. So we have t power 4, 3 minus 5 t power 5 x, 1 by 3. The value of dt is dx divided by minus 25 t power 4. This t power 4 cancels with this t power 4. We take minus 1 over 25 outside, and here we have x to power 1 by 3 dx. So our integral, which was previously in terms of t, is now entirely written in the form of x. And we know that how to solve this integral by power rule of integration. So we have 1 over 3 as the power. We will add 1 into it and the same power in denominator. So we have minus 1 over 25 x to power 4 by 3 divided by 4 by 3. So we can bring this 4 by 3 up and can write it as minus 3 by 25 into 4 x to power 4 by 3 plus some constant, which could be written as minus 3 by 100 x to power 4 by 3 plus some constant. And we have solved this integral. Let's solve another very simple integral, integral e power minus 5x dx. Since there isn't any direct formula to solve this integral, but we know that e power x dx is equal to e power x. So see here, the power on e is simple x, and then answer is e power x. So what we are going to do is we are going to make this substitution minus 5x here equal to t, because this way we can have a single variable as the power on e. Also, when we suppose minus 5x equal to another variable, we have to ensure that the derivative is also there. But the derivative of minus 5x is minus 5, and minus 5 is a constant which will be adjusted later. So we will go ahead with this substitution. So minus 5x equal to t is differential minus 5 dx is equal to dt, and the value of dx is dt by 5 and minus sign. Let's put minus 5x equal to t and dx value back in our integral. We have e power minus 5x equal to t, dx is minus dt by 5, and we have taken minus 1 by 5 outside. This is a very simple integral, and now we can solve this integral e power t dt by using this formula. So e power t dt by using this formula is just e power t plus some constant. So we have seen that the answer of the integral e power minus 5x dx is simply e power minus 5x multiplied by minus 1 over 5 plus some constant. Let's solve another integral. This time we have 2x plus 7 into x square plus 7x plus 3 4 by 5 dx. Now before we solve this integral, let's see that this integral has two parts. One is 2x plus 7 and another is x square plus 7x plus 3 whole power 4 by 5. We can see that this part is the complex part. So from the complex part, we are going to look for a tiny part such that its derivative is also here. So the tiny part is x square plus 7x plus 3. We are going to suppose it equal to another variable, but before that we have to ensure that its derivative is also written here. What is the derivative of x square plus 7x plus 3? It is 2x plus 7, which is written here. So we are going to suppose it equal to t differential x square differential is 2x dx, 7x differential is 7 dx, 3 differential is 0 because it's a constant. It's just like the derivative of a constant is 0, equal differential of t, which is dt. Here dx is common, so we will take it out, dt, and the value of dx here is dt by 2x plus 7. Let's put this value and dx is equal to dt by 2x plus 7 back in our integral. So we have 2x plus 7. In the place of x square plus 7x plus 3, we will write t power 4 by 5, and the value of dx is dt by 2x plus 7. We can see that this 2x plus 7 is cancelled out with this 2x plus 7, and we have t power 4 by 5 into dt. Now by simply using power rule of integration, we have t 4 by 5 plus 1 divided by 4 by 5 plus 1, which gives us t 9 by 5 divided by 9 by 5, which can be written as 5 by 9 t power 9 by 5. But t was originally not the part of our question, so in the place of t we will put the value of t, which is x square plus 7x plus 3 whole power 9 by 5 plus some constant. This is how we use substitution to solve this question of integration. Let's attempt another question where we have to find the solution of this integral x square square root x minus 1 dx. Now this question has two parts. One is x square, another is x minus 1 square root. Usually what we do is, from the complex part we think of its tiny part and put it equal to our different variables such that its derivative is also there. Here the complex part is square root x minus 1, so its tiny part is x minus 1. We are going to put this equal to t, but before that we have to think that the derivative of x minus 1 is also here. Derivative of x minus 1 is just 1, which is, let's say, written here. So let's go ahead with this substitution. Differential of x minus 1 is dx minus 0, because derivative of 1 is 0, so differential of 1 is also 0, and differential of t is dt. So we have dx is equal to dt. Let's put the value of x minus 1 equal to t and dx is equal to dt back in our integral. We have x square square root x minus 1 is equal to t, dx is dt. But see, after making this substitution, our integral is in the mix of variables x and t. This should not be like this. After the substitution, the whole integral should be only in one variable. So we have to fix that. How we can do that? We see that from this substitution, x minus 1 equal to t. So from here we can find the value of x, which is x is equal to t plus 1. So in the place of x we can put x value, which is t plus 1 whole square root t dt. Now by using the a plus b whole square formula, which is equal to a square plus b square plus 2ab, we can open up t plus 1 whole square, which gives us t square plus 1 plus 2t multiplied by square root t. So now we can multiply square root t inside, t square into t power 1 by 2 plus t power 1 by 2 plus 2t into t power 1 by 2. In this term, since bases are same and these two terms are being multiplied, so we will add up the powers. T 2 plus 1 by 2, t power 1 by 2 plus 2t 1 plus 1 by 2, and we will integrate it with respect to t. Here we have t power 5 by 2 plus t power 1 by 2 plus 2 t power 3 by 2, and we will integrate it with respect to t. Now let's separate these terms. T power 5 by 2 integral, t power 1 by 2 integral, 2 is the constant outside, t power 3 by 2 integral. Let's find these integrals by the power rule of integration. T power 5 by 2 plus 1 divided by 5 by 2 plus 1 plus t power 1 by 2 plus 1 divided by 1 by 2 plus 1 plus 2 t power 3 by 2 plus 1 divided by 3 by 2 plus 1. So we solve this. T power 7 by 2 divided by 7 by 2 plus t power 3 by 2 divided by 3 by 2 plus 2 t power 5 by 2 divided by 5 by 2. Let's simplify this further. It is 2 by 7, t power 7 by 2, 2 by 3, t power 3 by 2, 5 by 2 goes up and becomes 2 by 5, and 2 by 5 multiplied by 2 gives us 4 by 5, t power 5 by 2. But in the beginning t was taken as x minus 1. So we will put here t as x minus 1 plus some constant. So we have solved this question by substitution. So the rule of the substitution usually is, from the complex part, think of its tiny part, put it equal to a different variable, and then go ahead. Here the complex part was the square root 1. So from inside the square root we put x minus 1 equal to t. But before we put x minus 1 equal to a different variable, we have to ensure that x minus 1 derivative, which we are putting equal to another variable, its derivative is also there. The derivative of x minus 1 was 1, and 1 is technically here like this. So we make this substitution and continue to solve it till the very end. Let's solve another problem. We have to solve this integral y square root 1 plus 2y square dy. Let's look at this problem. Here the integral has two terms. One is y, another is 1 plus 2y square root. From among these two terms, the complex term is the square root 1. The rule for the substitution says, from the complex part, think of its tiny part such that the derivative of that tiny part is written inside this integral. Let's suppose 1 plus 2y square equal to another variable, but before that, what is the derivative of 1 plus 2y square, which should be written here? The derivative of 1 plus 2y square is 0 plus 4y. that is it's 4y. So we can see y written here but not 4, but 4 is a constant, so it will be adjusted later on. So we'll go ahead with this substitution and put 1 plus 2y square equal to t. Differential of a constant is 0 plus differential of 2y square, which is 4y, and then the differential of y, which is dy, equal to differential of t, which is dt. From here the value of dy is dt by 4y. So we will put 1 plus 2y square equal to t and the value of dy back in our integral. It gives us y square root 1 plus 2y square is t, and the value of dy is dt by 4y. We cancel this y with this y and we have square root t dt. So our integral, which was initially y into square root 1 plus 2y square dy, is now written in a simplified form, which is 1 over 4 integral square root t dt. And we can solve this integral by power rule of integration, which is by adding 1 into the power 1 by 2. In denominator we have 1 over 2 plus 1, some constant. We can write it as 1 over 4 t power 3 by 2 over 3 by 2, and when this 3 by 2 goes up it becomes 2 by 3. 2 divided by 3 into 4, which is 12. So t power 3 by 2 plus some constant. We make this simplification and we have 1 over 6 t power 3 by 2 plus some constant. So we have solved this integrals, which was y into square root 1 plus 2y square dy, by making this substitution. Let's solve another integral. Here we have the integral e power x over 1 plus e power x dx. We are going to solve this by substitution. Now think of something here such that its derivative is also written here. We can see e power x and the derivative of e power x is also written here. What we are going to suppose is 1 plus e power x equal to our different variable. But before that we have to check that is the derivative of 1 plus e power x also written here. The derivative of 1 plus e power x is 0 plus e power x, which is just e power x, and e power x is written here. So we'll go ahead with this substitution and put 1 plus e power x equal to t. The differential of 1 is 0. Differential of e power x is e power x, and then differential of x, which is dx, is equal to dt. From here the value of dx is dt by e power x. So let's put 1 plus ex is equal to t and the value of dx back in our integral. We will see we have e power x as it is divided by 1 plus e power x equal to t, and the value of dx is dt by e power x. We can see that e power x cancels out with this e power x and we have 1 over t dt. Our integral is entirely converted into the variable t form, and now we know the formula 1 over x dx integral is ln x. So we are going to write 1 over t dt integral as ln t plus some constant, but t was not originally the part of our question, so we will put the value of t from here, which is 1 plus e power x plus some constant. So this is how we solve this question by substitution. Let's do another question. This time we have integral dx over x ln x. We are going to solve this question by substitution. Put that term equal to t such that its derivative is here. We know that ln x derivative is 1 over x. So we are going to suppose ln x equal to another variable because its derivative is 1 over x and it is written here. So put ln x equal to t. Its differential is 1 over x dx is equal to dt. Dx is equal to x dt. put ln x equal to t and dx is equal to x dt back in our integral. The value of dx is x dt, denominator x, and ln x is taken as t. This x cancels with this x and we have 1 over t dt. By the formula of integration 1 over x dx is equal to ln x, we can write this integral as ln t plus some constant, but t was taken here as ln x, so we will put ln in the place of t ln x plus some constant. So we have solved this problem. Let's find the solution of this integral dx by square root x into x plus 1, and we are going to solve this problem by substitution. We can see that this problem has square root x in it and x plus 1. Usually the term that involves the square root in it is the complex one. We can have a look at this integral and go ahead with the substitution x plus 1 equal to t, but you will see that x plus 1 equal to t does not simplify this integral. So what we are going to do is we are going to suppose square root x equal to t and try to see if this substitution converts this integral entirely in the form of t. If it happens, then it means that this substitution is correct. Square root x equal to t, its differential 1 over 2 x to power 1 by 2 minus 1 dx is equal to dt gives us 1 over 2 x to power minus 1 by 2 dx is equal to dt gives us 1 over 2 square root x dx is equal to dt gives us the value of dx, which is 2 square root x dt. Let's put square root x equal to t and the value of dx in our integral. Dx is 2 square root x dt divided by square root x was taken as t into x plus 1. We can already see that this substitution square root x equal to t has not converted our whole integral in the form of just one variable. So we are going to fix this. We know that we have taken square root x equal to t, so this square root x is t dt divided by t, and okay, this was the substitution. Square root x is equal to t, we take square both sides, we get x is equal to t square, and here in the place of x we are going to put t square plus 1. Let's simplify this. This t cancels out with this t and we take 2 outside. Inside we have dt by 1 plus t square, and we know this formula of integration dx over 1 plus x square is equal to tan inverse x. So we can write here in our question 2 into tan inverse t, but t was taken to be as square root x, so we will put here 2 tan inverse square root x plus some constant, and this is how we solve this simple problem. Let's solve one more question. We have to find the integral of cos cube x sin x dx. We can see that this question has inside the integral 2 parts. One is cos x and we can put here as the whole power, and another is sin x. So here we have 2 parts, cos x to power 3 and the second part is sin x, and the complex part is definitely cos x to whole power 3. So from the complex part we are going to think of its tiny part. Let's say it is cos x and put it equal to another variable, but before that we have to see that the derivative of cos x is here. Derivative of cos x is minus sin x. Sin x is here but not minus, but minus is like -1, which is a constant, and constant is not a problem. It will be adjusted later. So we are going to go ahead with this substitution, and we are supposing cos x equal to t. Then we find the differential. Minus sin x dx is dt. The value of dx is dt by sin x and the minus sign. Let's put cos x equal to t and the value of dx in our integral. Cos x is t cube, sin x as it is, the value of dx is dt, we are taking minus sign out, divided by sin x. Let's simplify this integral. Sin x cancels out with this sin x, minus t cube dt, and we can solve this simple integral by power rule of integration, which gives us t power 4 by 4 plus some constant. But t was taken to be cos x, so we have minus cos x to power 4 divided by 4 plus c. So this is how we solve integrals by the method of substitution. In the next video, we will try to solve the integrals by using the method of integration by parts.